Hi, welcome back to another video. I recorded this video a while back, but the audio got messed up, so I'm re-recording this again. This has been there in my to-do list for a very long time. Every time when I meet somebody, the most common question I get is how do I get into ML research? That is a separate topic, and we'll cover it some other day. And another common question is a lot of my friends are software engineers and they see things around AI and they see tools which uses AI which are built around AI and they want to learn how to work with AI. So that is the whole purpose of this video. What are all software engineer needs to know to get started with AI engineering? What I noticed is there is a lot of gatekeeping, as well as if you go Google any of these topics on the internet, you would see like an hour long video. Suppose I just googled a while back. You see, I just typed MCP, and I saw a 40-minute video here and 1 hour long video here, and then you can see some random complex no diagrams being drawn here and to explain what MCP is. You can see the people keep adding additional complexity, but I wanted to make sure that uh, so from the outsider perspective, this looks something very complex, but the aim of this video is to make things very simple because, to be honest, it is not very difficult to integrate AI into your software. My main aim is to just teach you the fundamentals of all these concepts, and you can start building softwares on top of it. So my main aim is to try teach you the basic fundamentals, and personally, according to me, most of it are buzzwords, and the underlining technology is very simple. Like if you want to learn really about how language model works and how each part of an LLM works, that is a different skill. That is something that is a different world. But if you want to build softwares with AI, it doesn't have to be this difficult. It doesn't have to be this complex. I'm structuring this video in such a way that an absolute beginner should also understand stuff, and gradually let's go from one topic to another. So that's why I'm just starting with prompts. I know that no, by now everybody know what prompt is, so I'll make sure that I will add the appropriate timestamp so that you can skip sections and you can like directly jump to other concepts as well. Let's get started. Okay, before we start with prompts, let's first understand what language models are. So what happens is the model is trained with a lot of data, and when you give some text input, it just tries to predict the corresponding output for that input, and then it returns back the text. This is the high level understanding of what language models are. So to access a large language model, the input has to be text. It doesn't have to be a text all the time because there is a model called vision models or multi models. You might have seen this Ghibli trend, right? All those comes under this vision models. What vision model does is when you send in an input image, it just has a vision encoder, and then it converts that image into because this language model can understand a certain kind of input only, so this converts into that side a certain kind of input and then processes it, and then there's a bunch of steps that happens. I will cover it in some other video, and then it returns back. So for now we know a bunch of large language model that is available, like OpenAI, Claude, Grok, DeepSeek, Qwen, Kimi. The list keeps growing on and on and on. So for all these models, few models are multimodal. Now let's just focus on text-based model alone. So for a text-based LLM, what happens is we give an input text and then we receive an output text. Correct? So the input text which we give in is called prompts. So I've opened Claude here and I am asking a simple question called what is the capital of India, and then it returns the capital of India as New Delhi. Here the capital, what is the capital of India? This text is called prompt. So these can be implemented programmatically as well. And for this whole video explanation, I've created a bunch of code so that I could go through code, because we as a software engineers, our main aim is to write code to integrate AI, right? So the right way to teach is via code. So I have written everything here in Python so that it will be easy for everybody to get started. So for this case of this demo, I have used an abstraction, Gemini's abstraction, because I don't want to write every individual step by myself, but it is a good exercise for you to write all those steps, because this is nothing but you're gonna hit an HTTP endpoint, a Gemini's HTTP endpoint with your API key, API key and prompt, and it just returns the response. It just returns the response back. So all this abstraction is done by these packages. You can use whatever package you want. So since I'm using a Gemini, since I have a Gemini API key, I've used a Gemini package here to do this whole demonstration. So I've loaded the Gemini API key from the environment variable, and then what I'm doing is I'm selecting the model. I use a model called Gemini 2 Flash. It doesn't matter, it can be anything. I'm using that, and you see this is the question I'm asking: what is the capital of India? So for now let's ignore this. So just focus on what is the capital of India. When we try to understand skills, I will I will connect the dots and explain you what is this additional prompt which I am giving. I am giving an input, what is the capital of India, and so now what happens is there is an HTTP request with the API key as well as this prompt, and then I get a response back. Response will be in response to the prompt which we have given. So let's just see a demo. So yeah, so when I run this code, I am seeing an output as the capital of India is New Delhi, which is exactly the same. So because the interface just changes, here it is chat, there it is API, but internally the same API has been hit. This is Claude, but that is Gemini. So understanding prompt is very important because that is the way you can communicate with the large language models. So understanding how to write good prompt is very important, and understanding what prompts is very important because that is the most fundamental thing you need to know if you wanted to build an AI related software. As well as a good prompt will make work easier for LLM to give you the correct answer. It is just very obvious, right? So you give proper and good instruction, it responds you back with the accurate answer. So next we can see what do I mean by this LLMs are stateless. This is a very key concept to understand because understanding this principle is the only way to build softwares around it. If you know this principle, then you can start thinking how can I build software around it. Let's see. Here is an example. So I am asking a question to an LLM, some random LLM, Gemini, Claude, or OpenAI, whatever. So I am asking what is the capital of India. Assume it is returning an answer called Chennai, and then immediately you are firing a next API request where you are letting that LLM know that you are wrong. But what will be the expected answer by the LLM? So you might think that what LLM will do is okay, sorry, it is not Chennai, it is New Delhi, and return back New Delhi. But it doesn't happen that way. Each individual calls which you fire to a large language model is stateless. So it doesn't store the state of the request. So the second request will have no idea that there was a first request fired with the question what is the capital of India, and the large language model has responded as Chennai. Without knowing this, how will the request B will correct its answer? Because it has no idea. So what do I mean by stateless is it doesn't have a history of the questions or history of the request that's been passed before. So every request is a fresh request. So it is our responsibility to make sure that we give adequate context to the large language model. So the right way to solve this is, or then how? Then you might even think that how does a chatbot work when I keep asking 10 questions and the 11th question if I reference the first question, how does the chatbot understand? Because technically each question is one API request, right? So what actually happens is you keep appending the questions one after the other, and then you start. For the first request, you will send what is the capital of what is capital of India, and it responds Chennai. For the next request, you will send what is the capital of India, as well as the answer which returned by the LLM, as well as the next question. And this keeps going on and on and on. For second question, you just appended the first question as well as the second question. Then for the 10th question, you will have 9 different answers as well as the 10th question. Only then it can understand the first question. So if you fire the 100th question, then that means you will have 99 question baggage, and that will be passed over the network for that call, right? So they solve this by sending this huge chunk of text. Once it reaches certain limit, they send to LLM and summarize the text, and now they have just a summary of what happened until now. This is called compaction. So they just summarize the text, and from now on the summary will go along with the newer question, and they keep summarizing on and on and on. The most important thing you should understand is LLM requests are stateless. If you wanted to give adequate context to the LLM, it is your responsibility to know. It is your responsibility to compile all the data into your prompt and send it to LLM. So now we've learned that LLMs are stateless. Next, we'll understand what tools are. So tools are an important primitives in building softwares with AI. Tools are very helpful because tools allow us to orchestrate the LLM as well as the complex functions which we write on our own. Tools might sound scary, and another way you can call tools as function calls as well. So now I will dissect these tools, so that understanding tools is very important for us to understanding MCP skills, or anything to do with building softwares with AI. Okay, this is the setup we have. We have a code that we call it as orchestrator. What orchestrator will do is it will fire an HTTP request to the LLM. It will get back the response. It will again fire a response, and this layer is our orchestrator layer. And we have an LLM here. It can be any LLM. And then we have a complex core application logic. That logic can be in any language. The orchestrator can be in any language. All you need to do is trigger an HTTP request to the LLM. So this is the code which I call it as orchestrator. You can see it is just 3-4 lines here, because now all the abstraction is given by Gemini for us. But you can write your own orchestrator layer. So it is very simple to write your own orchestrator layer, and I highly recommend you to write one. So I call this as the complex function. This is a very simple example of adding two numbers. Assume that no function can be very complex, like getting access to your AWS, downloading files from the S3, modifying the files, and then going again to SharePoint and downloading some files, modifying it, uploading back to S3. Let's take a scenario like this, that you need to do 10 different steps, one after the another, and all the steps are very complex. Or you can't so now you can't ask LLM to go do the 10 different steps, right? It will definitely mess things up. You need to pass your secrets to large language models. You have to pass the access keys to large language model. You have to make sure that it calls the right endpoint, because sometimes it might have a knowledge cutoff, so the API or the endpoint might be deprecated. So in all these cases, now how do I execute such a complex scenario with the help of LLM? Tools are nothing but it is nothing scary. It is just some function that we write here. Just so for this example, I have taken adding two number A and B. There are two ways to do it. One is LLM can perform the task. So the task which I told before, right, it is a complex task. You can write n number of prompts and a huge page of prompt and make LLM to do it. That is also one way you can make it work. But the better way to do is, so instead of LLM figuring it out how to run this complex function, you can write the complex function and execute that. So this is the setup. We have an orchestrator layer, which is just which is just this 4 lines, and then we have a complex function, and the LLM which I am calling is Gemini. Which is the LLM. Let's take this use case of adding two numbers and see how this tool works. Step 1, what I am doing is I'm going to send a prompt. Obviously, that is the only way you can talk to that LLM, right? I'm going to let LLM know that I want to add two numbers. Along with the prompt, or before or along with the prompt, you expose a bunch of tools. You can say that, so these are the tools that are available. I have a tool to add two numbers. So when you encounter a case where the user asks you to add two numbers, use that tool instead of you doing the computation. Literally telling to the LLM that you don't do this task. If it is this task, let me know, I will do it. So you can either preload this tool, these are the tools available beforehand, so that LLM has an idea of what are the tools it has, or send it via when you send the question also. That is also fine. Whatever you need to indicate LLMs that these tools are available. So for this use case, I am letting LLM know beforehand itself. This is the tool which I have. I have a tool which is nothing but this function. If the user asks me to add two number, there is a function A that exists, which is a tool. There is a tool that exists. So I am letting LLM know that the tool exists. So now when I am requesting for add 5 plus 2, what happens is LLM looks at the tool list which are available and it finds that so what happens is instead of LLM doing the calculation or LLM doing that complex logic, for this case adding two numbers, so instead of LLM doing it, it responds back saying that go use that tool. Some flag, it can be anything, it depends on the orchestrator. Some way to let our orchestrator know that use the tool, don't do it by yourself. The orchestrator has received a response, it receives an indication or it receives a signal from LLM that you need to be using a tool call, yeah, and I won't give you the answer. You can implement it however you want. It can be some flag, it can be some tool indication, some flag or something. It all depends upon the orchestrator code, the way you structure orchestrator code. So now LLM has informed you that you need to use tool call. You could as part of orchestration, you could have a bunch of switch case. Suppose if LLM returns tool X, I will call the tool X. Returns tool Y, I will call the tool Y, and so on. And as per the prompt, you can let LLM know that if it is a tool call, return this, return that, so that it will exactly return that. And from now from your orchestrator, you will go call that function. One key confusion people have related to tool, that they think that LLM executes the tool. No, LLM doesn't executes the tool. The local code which you have, the orchestrator which you've written is executing your function. The LLM has, in fact, the LLM has no idea what is inside that tool. Also, it doesn't even understand the code inside it. All it needs to know is a doc string or whatever what that function does, and it doesn't even load anything else inside. So once the orchestrator has received a signal from that LLM, it runs this local function in your local machine. LLM has nothing to do here. Its job is to identify to use a tool call, and its job is done. Now you run this function, and that function runs in your local machine and responds the answer. Why is this important? So I gave you an example, right? Very very complex logic which involves 10 to 20 different steps. You can't let a non-deterministic system run 10 to 20 different steps and make sure the results are accurate, things are being called correctly. All LLM does is it just responds back that you have a tool by yourself. It is better you run that by yourself. So you have a tool which is better than me. So run this tool by yourself. Let me show you an example. So this is our orchestrator. So orchestrator, I am saying this is the model, Gemini 2 Flash. And I'm saying this is the prompt. What is 3 plus 5? That is the prompt. But you note that, so as part of config, I'm sending a tool add here. So that means I'm registering to that LLM. You can do it here, or you can do it beforehand itself. Let LLM know that this tool exists and then start sending questions. Everything works fine, because again the concept is in continuation. LLM calls are stateless. So you need to make sure that every request you have to register that this tool exists. So now we've registered that there is a tool called add. What this orchestrator technically do is it just sends the function definition. That is, here it is 2 numbers. So there is a bug here. I have placed a bug at line number 11. This is a very very important thing in building softwares with the AI. Prompts are everything. Clarity of prompts are everything. So instead of you writing these 2 numbers, what does LLM infer from these 2 numbers? Nothing. Instead, if it is add two numbers together, then the LLM might understand, okay, there's a tool registered which can add 2 numbers together. So when I give an input add 3 plus 5, it will give back a signal telling the orchestrator that use your tool instead of doing it. So if it is blunt 2 numbers, then if you ask it to add 3 plus 5, then it won't understand that there is one tool exists that which adds 2 number, wrong and vague description. Since adding 3 plus 5 is a very simple task, you might think that LLM might do it by itself. So what I have done is I have added a print statement called this tool is been called. So now when I run this code, there are only 2 things that can happen. One is LLM runs this 5 plus 3 by itself and computes and sends back the answer. 2, it returns back there is a tool exists, and our orchestrator calls the local function and it runs that. You can clearly see that if the LLM would have ran it by itself, it would have directly added this 5 plus 3 and returned 8. Since it has called our tool, this print statement has executed that this tool has been called, which just confirms that it has called this tool instead of directly computing it by itself. So, long story short, tools are nothing but your local functions, which your local complex function. It can be complex, it can be simple, it can do whatever you want. It's a local function, but a well-defined local function, and you expose that tool to the LLM. Not all the codes in the tool goes to the LLM. Just the idea that it's just kind of a mapping that these are the docstring. If this description matches, call this tool call. It doesn't even have to know the exact code into it. So you write your local function, you define that local function, you expose that definition to the LLM beforehand as part of tools. So whenever that tool is needed, instead of LLM calculating or finding or doing things by itself, it just returns back some signal to our orchestrator saying that you have a local tool, run that, and our orchestrator just calls this tool and then it runs in the local. A good exercise for you to do is to write your own orchestrator layer, because it is very straightforward. How do you do it? So you fire an HTTP request, and as part of prompt you need to say that if it exposes a tool, return back ABC, and then you write an if case. If ABC, then you will do a function call in the local. I'll write a quick pseudocode and show you guys how you can design your own orchestrator layer. Step 1 is you expose all the tool definition. Step 2 is you fire an LLM request with the right prompt. Step 3 is LLM response something. By right prompt, what I mean is it can be anything. It depends on your orchestrator layer. Sometimes I can write that if there is a tool call necessary, return me tool is to tool name. No, LLM responds back tool is to tool name, and you can have an if case. If it is tool is to tool name, call some local function yeah. So call a local function, and this keeps going on and on and on. This is a very simple orchestration layer, and the beauty is you can add your own creativity, figure out a way how you can creatively make sure that it works properly. I hope you understood what tools are, because these tools are very necessary for you to understand all other stuff, because this is the only way to build understand tools are the gateway of building remotely complex systems, because without tools you can't let LLM do anything, because in the end you have all the code, you have all the legacy code which been written 30-40 years, and you need to figure out a way for the LLM to you need to figure out a way for LLM and your local functions to work together. So tools are a very good way to make this happen. What are the drawbacks in these tools? The obvious there are few drawbacks which are obvious and which occurs in all of these LLM related problems. One is the context limit, because you can suppose you expose 20 to 30 different tools, then it becomes a little difficult for the LLM to figure out which is the right tool and respond back. That is one problem exists throughout, and you should make sure that the prompts are concise, but the prompts are clear, and just expose very limited tools instead of exposing all kinds of tools. And all of these are very engineering problems. One problem exists throughout is context window of the LLM. It can just hold only n number of tokens, and you should play around, figure out way to utilize that. If you overload the LLM with a lot of tools, the problem which you will face is either the LLM might not even choose the correct tools, or it will have too much options and it might choose a wrong tool as well. So that is something you need to consider and design when you build software with tools. So now we've covered tools. MCP is called Model Context Protocol. It is one of the most hyped protocols. Wherever you look at the internet, people talk about MCP. People talk about MCP on Reddit. People talk about MCP on LinkedIn, Twitter, everywhere. Fun fact is there are more number of people building with MCP than more number of MCPs in production. That is the obvious truth. Remember that it's just an overhyped protocol, and you won't find a lot of MCP servers in production. You can actually find a lot of MCP servers in your local machine having a cool demo. you using MCP servers as part of your development, but it is very very rare to find MCP servers in production because it has a lot of limitations. And now we'll explore what MCP is, what are its limitations, what it can do. And then if you just go to the Model Context Protocol website by Anthropic. So MCP is introduced by Anthropic and now it is a very standard protocol. At the start of this video, I would have shown you a bunch of YouTube videos which talks more than an hour, 2 hours, like showing very complex diagrams, complex graphs and everything related to MCP. And if you go to the official MCP documentation also, you will see a lot of stuff here, like MCP server, client, versioning, how to deploy with MCP, all of it. So my aim of this video is not to sell MCP for you. Rather, I would like to just explain you what MCP is. After my explanation, you will understand how simple MCP is. But it is just remember that it's just an overhyped protocol. Let's get started. It is very easy to understand if you understand tools clearly. Let's take the same example. In tools, we have a function written locally by us. Assume you don't want to manage this function. Assume you don't want to do anything related to it. So what you can do is you can just move this away and somebody else maintains it for you. Okay, so what if we don't want to maintain this function? We don't want to run a server, or we don't want to maintain our function or do anything by ourselves, and some third party MCP server exists, and instead of function calls or tool calls done in your local, you go to that remote server and make the tool call. It is nothing but MCP servers. This MCP server is nothing but take the tool call, strip it off from your code, run it as a separate server, and you keep hitting that separate server. Then that separate server is called MCP server. Why do you even need an MCP server? I will take an example for you. Assume you have a Google Drive functionality where there's a bunch of complex code related to Google Drive, like downloading from Drive, doing authentication, doing this, that, and everything. Instead of you writing that and maintaining, I mean that when there is a security update, you have to update it. When there is some changes, you have to do it. You have to take the complete responsibility of that code. Instead of that, what if Google has officially given you an MCP server to call? That means instead of this in your local code, it moves somewhere outside, where Google has officially given you an MCP server, and all you need to do is your orchestrator calls this MCP server instead of your own function. So inside this MCP server, there is nothing magical happening. There is the same tool call, there is a couple of additional functionality which I will talk about, but inside this MCP server there is nothing very special. It is just a server which is somewhere else, which runs the exact tool call which we talked about earlier. Let's see the flow here. So step 1, what happens is, earlier you just sent we'll compare it with tool call so that it will be easier for you to understand. Step 1, you sent a question and along with the tool definition. Here you would send along with the tool definition, you will send the MCP server definition. So what LLM will do is, it needs an idea of what are all the tools that the MCP server has, so that whenever a task related to MCP server occurs, it delegates that to the MCP server. Similar to tool call, you just send a doc string or some definition of what that tool does, right? Similarly, you need to know what are the tools that the MCP server has. How do you know? You just send an HTTP. Our orchestrator sends an HTTP to the MCP server, get all the tool definition, and then returns that to LLM. So now LLM has an idea of what are all the tools that MCP server has. Why it is necessary? Because the flow is very similar to tool call, and the LLM identifies that we have an MCP server which has all of these tools. So what happens is, it signals our orchestrator that instead of me calculating, go call that MCP server. That MCP server has the tools which you need to execute this. The step 3 happens, and the MCP server calculates the does whatever task it is asked to do, and it returns the response. Very very standard, very very similar to tool call, but it is just moved away. That's all there in MCP server. But there are a bunch of additional functionality, but which nobody uses. But this is all there in MCP server for you to understand. So we can understand this MCP server clearly, and I will show you a bunch of code also, and the additional features that MCP server offers. Assume this is one server that is running separately. So when you hit some endpoint which just lists all the resources. So there is a concept called resources. So just like how we use MCP for tools, right? You can use this MCP for resources. That means if the orchestrator requests from data from this slash users, we can write its corresponding features. Like if it is data slash user, I'll go fetch from a DB and then get back and send to you. You can do the exact same using a tool call. That means if a tool call ABC is triggered, I'll go and fetch it from the database and get back. You can still do it with the with tools with the tool implementation of MCP. All the list function here. So this list resources. So this will be first fetched by our orchestrator, and it will be fed into LLMs, and it will have a context of all the resources available. What you can do is you can define as many tools as you want in the MCP server. So here I have defined two tools. One tool is to add two numbers together, and these are the input schema. Similarly, another tool is to reverse a string, and these are the input schema. So you can define as many tools as you want. And what our orchestrated layer does is first lists all the tools which are available in the MCP server. It'll call this function. It'll hit an endpoint. That endpoint will call this. It'll hit an endpoint which is nothing but this function, and it returns this. It'll return all the available tools, and it'll load all this data into our LLM. So now LLM have an exposure that these are the tools available, these are the input parameters, these are the descriptions. And what technically model context protocol is, it defines the schema. Why is this schema definition is very important? That is, it defines what kind of schema needs to be input, what kind of schema needs to be the output. Why is this very important? Today I showed you an example of G Drive. And another very popular MCP server available is Figma. Assume there is a Figma MCP server here. So you have a G Drive MCP server and a Figma MCP server. Both has to have a very similar input and output definition. Else, if each and every MCP server follows their own semantics, it will become for us difficult for us to write MCP server as well as consume data from the MCP server. As part of standardization, all the AI labs have agreed to this particular format, so that people can everybody use this input format, everybody use this output format, and everybody use this tool definition and so on. There's one more thing called prompt which is available in MCP. Nobody uses this, absolutely nobody. So assume you have some prompts in the local. Instead of maintaining all the prompts, you write the prompt in the MCP server, and then expose that these are the prompt available. When you needed it, you go request from the MCP server. It will return back all the prompts needed. So you can use this as a centralized prompt storing mechanism, where you will have all these prompts in one place, and then definition of that prompt. And whenever the LLM needs that particular prompt, it'll let the orchestrator know that orchestrator needs to go look at the MCP server for that particular prompt, and then the MCP server returns the prompt. Why people don't use it? Because just like how we have secret manager, most of the organization or most places we use a prompt manager. Just like how you store secrets, you store it in prompt manager. So it is just a very deterministic call. What happens inside the prompt and after you get the prompt and call the LLM is non-deterministic, because LLM can return any answer. But whether you need a prompt or not is always deterministic, because prompt is the way you send input to an LLM, and you always know that you need to send some input to LLM. Since most of the companies subscribe to a prompt manager like Amazon prompt manager or whatever, and you can just do a direct request, like how you fetch secret from the secret manager, and you get the prompt and then directly stuff it inside the LLM. So people don't use this as well. The only use case of having an MCP server is this tools. So the companies or organization by themselves write all these tools and all these MCP, all the tools and all the tool definitions. That is what the tool exactly needs to do, and they keep maintaining it. And our LLM need to expose that MCP server. That one thing which we need to do is let LLM know that there is this MCP server that exists, and you can use that MCP server. and then whenever it needs, it lets orchestrator know that go call MCP server again. Just very same as tool calling, LLM doesn't go directly call the MCP server. It just lets it just signals our orchestrator layer that you got to go and fetch data from the MCP server. You see an request of a particular structure, response of a particular structure, the MCP tool definition is a particular structure. This is what model context protocol defines. Things has to be in the particular structure so that it is standardized and everybody use it. I told that people don't use it a lot in production, or it is very rare to find a proper MCP server in production. What is the reason? What are the drawbacks in this MCP server? First, it is a bad abstraction. When I was explaining tools, all you need to do is or tell them what this tool does, and you don't need to know anything more than that. Example, you need for adding two numbers, all you need to tell LLM is, so whenever you need to add two numbers, use this function. This is all you need to let LLM know. Because of this abstraction, that is, you see here, right? The tools will have a name, description, input schema, blah blah blah. It just keeps blotting and blotting and blotting. And one major problem why you can't find a lot of MCP server in production is because it just overloads the context. If you use a Opus model or something very powerful, you might see a crazy bill, and the main reason you have such bill is because of this MCP server. Assume there is 50 different tools like this. Each tool, instead of just having name and description, or even it can be a little shorter, it will have all this bunch of unwanted details. Or if you have a bunch of resources, it will have all these resources and a bunch of details, and it will all blot your context. So every request, instead of just one single line or a bunch of lines, you send all this input in and out, which is a major drawback of MCP servers. Another thing is latency. Obviously, if you run the server in your local, there is not a problem. This problem doesn't happen in tool call or tool call, because it is just a function which is in your code, which is in your server. But MCP server by inherently means there is a separate server running. It can be inside your cluster or somewhere outside, doesn't matter. But there is always a latency, because for everything you want to do with MCP, you're gonna go hit that server, get the response back. So there is one latency part here. Already LLM is non-deterministic, so it will take whatever time it wants. Now you add another complexity of you add another layer of complexity of MCP servers. Now it will take even more time, and then there is a security nightmare and a difficult to debug. It is like a double-edged sword. You can say that I have now outsourced all my problems to some vendor. But there is also another problem, that if there is some error or something to debug, you most often than not, you might not get the logs, or might not get the details how the actual functionality has been implemented in that MCP server. So it becomes a security nightmare, and there is an difficult to debug as well. Security nightmare in the sense, now that MCP server is also part of your ecosystem, so you got to make sure that the MCP server is not exploited. One common problem with MCP server is it is prone to prompt injection. I can show you with this example. So suppose to add two numbers, I am just doing a plus b. So if I am able to hack into that MCP server and modify this a plus b into a into b, or something malicious, the response you get won't be correct. Suppose you use this prompt feature, and if I am able to get into that MCP server and go modify this prompt into something very malicious or something which I can get data out of it, which is a problem. So it is a security nightmare as well. Obviously there is a problem of reliability, because it is a separate server. You need to maintain it, you need to write observability, you need to make sure it is running all the time. There's a tool explosion problem, like I talked about in the beginning. Because of its bad abstraction, what happens is it just bloats a lot of context. The LLM needs to know all of these details beforehand for it to correctly point out that this request needs to be handled by an MCP server. So that is the problem here. There are like proper use cases where you could use an MCP server, especially when you are building code or when you are writing agentic code. That means you are heavily using Claude Code or whatever to write code. You could use MCP servers in a lot of different ways. One is like you can use on Figma MCP. If you are a front-end developer, you could connect Figma's MCP server with your Claude code, so that whenever you need to know about the design, you could just go that our Claude will go intelligently go to the Figma MCP and get those details implemented for you here. That is one way to use an MCP server. And another common way I see people using MCP server is to lint or format and do all those stuff here. So you can't ask LLM to go lint your code. Rather, you could write a deterministic linter, like for example, Golang CLI lint or PyLint, whatever. You've written MCP server, and there is one tool, and all it does is it just runs PyLint blah blah blah, and that server also runs in your local. So next time when Cloud Code writes something, at the end of it, you could let the Cloud Code lint it, and since you've loaded that MCP tool into that, the Cloud Code won't lint by itself. Rather, it will call our MCP server, and our MCP server is also in our local, so it'll do our linting. You might ask me that rather you could use a tool call here, right? But the one advantage of using an MCP server over direct tool call here is you can write MCP server once, and you can like share it with all the developers in your team, and everybody runs that server. If you want to add this tool call, then you should modify your code, and it should be part of your code so that this has been called by the function. That is the one advantage here. You can write one server, and that server runs in local to everybody, so you don't have to modify anything in your code. You have your own code. If you wanted to use tool call, you need to modify your tool call to accommodate those functions. You write those tool functions and write an orchestrator layer that calls this tool function. Rather that you would write a linter or which runs PyTest or whatever, PyTest, Go test or whatever, and this server also runs in your local. So and you expose this to your Cloud Code. So whenever you ask Cloud Code to lint a code, instead of Cloud Code trying to lint it by itself, it knows there is an MCP server in your local that exists. So it will go call that MCP server, and it will lint your code. So now what you can do is you can just commit this server in a separate code base, and you can commit the actual product in a separate code base, and all the developers will get access to this MCP server, and they can follow the same step. Just like how people confuse between MCP and tools, people also confuse between prompts and skills. Skills are something very new which is brought by again Anthropic. If I explain about skills, and you might even curse me that I'm wasting your time explaining all these things because it is that rudimentary. People are talking about skills these days, and skills are always hit and miss, and sometimes it works, sometimes most of the time it might not work. But you got to understand what skills are because it is very very simple. It will take less than 5 minutes for me to explain what skills are. So before that, how did this concept called skill got popular? Anthropic released something called skills, which is again a prompt file, which is again a text file, but I will explain what skills are. But how did it become popular? There is a man in San Francisco called Gary Tan. Gary Tan is a venture capitalist who leads a famous venture capitalist firm called Y Combinator, and he released a product called G Stack, and people keep trolling him, but that is another story. That is the reason how skills got popular. Not for a good reason, but at least skills got popular, and it got popularized across the world. I have a file called skill.md. Skills is nothing but a prompt file. There is not a lot of difference between prompt and skills. So you create some folder, it can be /skills or whatever folder, and you write a bunch of MD files, and so on each MD files you write a couple of lines explaining what that file denotes, and this file can be as long as like 400-500 lines easily, but you will have a line or two explaining what that skills is on top of that skill file. So technically you might have like 100 different skills, or you can even call it as prompt files, but we can call it skills here now. For now, you can have 100 different skills markdown files, and each of the files will have a couple of lines, couple or 3 lines. Basically what LLM does is it fetches approximately 100 tokens. It uses approximately the first 100 tokens of each file and loads into its memory. So now it does some kind of a mapping that it will have an for simplicity we'll consider it as first 2 lines. So now LLM will have 100 understanding of 100 different skills, because it does has the first two lines of all the prompt files. So whenever a prompt is needed, since we have the mapping, LLM would smartly come and identify that skills file, and then load all the 500 lines on demand. So instead of loading the 500 lines into 100 skill beforehand, we just give a bunch of skill definitions. They call it a skill definitions because to know what exactly the skill does. And LLM because it has the idea of what each skill does. Whenever skill is needed, it'll come to the skill.md, take all the data in there, and then loads into the LLM memory and start implementing it. It is nothing but a glorified version of prompt file. Then what is the difference between prompt and skills? So in prompt you just load everything beforehand. In skills you smartly load so you smartly first load the definition, and whenever you needed it, you load that prompt. It is nothing but skill. So here you see there is a bunch of structured way you write skill. You can write skill however you want, it doesn't matter. But ideally skills are nothing but, suppose in this prompt.py I've added what is the capital of India. Along with that, I've also added a prompt that also take a look at /skills for skills. Assume I write all the skills.md files under this /skills. So what happens is, suppose if you wanted to give an extended prompt, or you wanted to give extended instructions under /skills, I will have this file. It is something like create a word.x file, and it will have some blah blah definition. So now the LLM will first go through the skills folder and load all of the definition of what each and every skills do. After loading all of the skill definition, when you keep prompting LLM, if the LLM feels that it needs an additional context and we have a skill corresponding to that question which is asked, it will go to that corresponding skill file, load every line into the memory, which will act as the prompt for that LLM, and then keep performing the activities. That's it. There's nothing more complex to skills. I started with explaining you that skills are hit or miss, because suppose you have 1000 skills and now you have 1000 into 2 lines explaining what each skill does, and it is all to the discretion of the LLM to smartly identify the corresponding skill.md or this corresponding markdown file and load all the context. So it is sometimes hit or miss because it is extremely non-deterministic. So if you keep adding more and more skills, just like all the usual problems, this will get confused. It will not take the right skills, and all the problems unanimously exist. So now let's come back to what our Gary Tan sir has implemented. So what he has done is, he just went all out and made like 40-50,000 lines of different kinds of markdown files. So now when you run Claude at Opus model, it will now load the 40-50,000 markdown files of definitions, and whenever you need something, it will just go to the corresponding skill files and load it. There is nothing interesting here, or nothing breakthrough, or nothing unique here, right? But that is actually true for majority of the stuff which is been called as AI engineering. This idea is interesting because you could load a bunch of files and take 1 or 2 lines, but these things we would intuitively arrive to if we keep building some agent system. We don't have to like name it as a separate utility or separate technique and do this. Rather, if you keep writing a bunch of prompt files, and you will definitely come up with an idea to smartly load just the files you use. That is a very intuitive idea that everybody will get right. But they just rebranded it as skills just to sell, as usual, sell and make more hype. So what Gary Tan here does is, he has a bunch of skill file related to how he selects company, how he operates company, which companies needs to fund and all those. He has a manager skill and accountant skill, whatever. He has all the crap here. Since he's using a tool like Claude, it'll have all the skills loaded in it, and it'll know what it'll do is it'll just come and look at the prompt and inject the correct prompt into it, and it'll start working. And this is also hit or miss because he has like 40,000 or even more skills in it. That's it about skills, and that's it about whatever I wanted to cover today. What is the biggest takeaway from this video? The biggest takeaway I think you should have is you shouldn't most of the stuff which they do is just hype machine or basic software engineering principles, because there are very nuanced work like fine-tuning a large language model, inferencing a large language model, doing agentic breakthroughs, or making sure you create very good evolves to make sure your agent runs on all of those work. All of those work are very interesting, but a large portion of works involves just pure software engineering, and you do an API call to a black box. So you don't have to fear about all of these things and try incorporating in the softwares you build. I hope you like this video. I will come back with another video very soon. Thank you.